How can I make this fired heater more efficient?
Hi, I'm BD, a specialist in helping people like yourself improve their overall plant efficiency. An air preheater, APH, could save up to 15% on your fuel cost.
What's an air preheater and how would it save me fuel?
An air preheater can save you fuel by utilizing the wasted stack gases through preheating the combustion air to the burner. Did you know when firing natural or refinery gas, 90% of the flue gas is combustion air and only 10% fuel?
I understand that, but how does an air preheater reduce my fuel usage?
Your furnace is currently using ambient air. Let's assume the outside air is 60 degrees Fahrenheit or 15 degrees Celsius. Therefore, you need to heat all the combustion air from 60 degrees Fahrenheit to a typical furnace temperature of 2500 degrees Fahrenheit or 1370 degrees Celsius. This heater is inefficient. It's exhausting combustion flue gases to the atmosphere at 800 degrees Fahrenheit or 426 degrees Celsius. This hot gas can be utilized to preheat the combustion air up to 700 degrees Fahrenheit or 370 degrees Celsius, and now the fuel only needs to heat the combustion air from 700 degrees to 2500 degrees Fahrenheit.
Isn't it complicated to add an air preheater?
It's relatively simple. We use the stack damper to divert the hot gases to the air preheater located at ground level. Typically, we use an induced draft fan, ID fan, to pull or suck these gases from the stack and through the air preheater before returning to the stack on the other side of the damper. We use a forced draft fan, FD fan, to push the combustion air from the atmosphere through the air preheater to the burners.
That sounds great, but what happens if I lose a fan? I'd have to shut down the heater.
That's a very good observation. Currently, the unit operates on natural draft, meaning the stack supplies the necessary suction pressure to pull the combustion air through the burners and heater before discharging to the atmosphere. The new combustion ducts include dropout doors. Should a fan fail, these dropout doors fall open and the stack damper opens, returning the heater to its original natural draft design. We can even add guillotine dampers in the flue gas and air ducts to isolate the APH.
Shouldn't I be concerned about reducing my flue gas outlet temperature to achieve optimal efficiency? Doesn't this increase the chance of corrosion occurring in the cold end of the APH?
That's a very valid point. There are many ways to assist in corrosion prevention, including preheating the ambient air by using steam or water coils, bypassing cold combustion air around the APH, or recirculating hot air back to the FD fan. They all have their pros and cons, but the simplest solutions are cold air bypassing or hot air recirculation.
How does bypassing cold air around the APH help in preventing corrosion?
Bypassing a percentage of the cold combustion air around the APH helps to maintain the flue gas outlet temperature at or above the original design temperature. This is especially useful when reduced firing is required due to lower product flow. It can also be used when the ambient temperature drops, helping to maintain the cold end metal temperatures. The reduced airflow also decreases the heat transfer between the flue gas side and the air side, which is also beneficial in maintaining a higher metal temperature.
How do I calculate the cold end metal temperature?
A good way of ballparking the cold end metal temperature is to take the average of the flue gas outlet temperature and the combustion air inlet temperature. Thermocouples can also be installed to measure the actual temperature.
That sounds simple and easy to control. Are there any disadvantages to cold air bypassing?
There are two main disadvantages. Cold air bypassing doesn't prevent cold air from entering the air preheater, which can produce areas below the design cold end metal temperature. Also, the mixed temperature going to the burners will be lower than the design condition. If lower ambient temperatures persist for an extended period, then the loss of efficiency can be significant.
How does hot air recirculation differ from cold air bypassing?
They are similar in layout, requiring a duct connecting the cold air inlet and the hot air outlet sections. A damper controls the amount of flow through the duct. Usually, the hot air recirculation duct terminates at the inlet section of the FD fan. The FD fan pulls air from the hot air outlet duct to the inlet of the fan. The recirculated hot air mixes with the ambient cold air, raising the air temperature to the original design temperature or above. This eliminates cold air hitting the air preheater while maintaining the required cold end metal temperature. Additionally, the outlet air temperature to the burners remains at the design condition, resulting in no loss of temperature or efficiency.
What if my forced draft fan is limited and can't handle the increased flow required for recirculation?
A recirculation fan can be added. In this case, the hot air is ducted to the fan outlet, avoiding any increase in the FD fan flow.
This sounds like the best solution. Are there any disadvantages?
Due to the higher airflow passing through the APH, a slightly larger unit is required. Normally, 5% or less increased heating surface will accommodate most situations.
I'll need to evaluate this carefully, but it appears adding an APH can be a good economic choice to improve my efficiency.
We can help you with that. Based on your current operating and/or original design conditions, we can provide an accurate estimate of the total cost of installing your new APH or replacing or improving an existing system. If you have additional questions, please visit our website www.bdheat.com and ask our experts. Enter your question under Ask BD. Also, you can visit our group website www.bdgroupindustries.com to find out about our sister companies. BD Energy Systems, which specializes in steam methane reformers and other fired heaters, particularly in the ammonia, methanol and hydrogen plants, as well as ethylene furnaces. We also undertake complete plant studies from our Parish Plant Services division. BD Environmental Systems supplies thermal oxidizers, regenerative thermal oxidizers, and flares. Remember, you can always ask BD to solve your equipment problems.